Well, welcome. I hope there will be a little bit more people, but maybe they'll show up later. Oh, there's a lot of places. Okay, great. So welcome to the info session for BISC-E. Today is going to be 3 parts of talk. We'll start with Edwin telling something more about the bio-based economy. Then we have Teun joining us online. He participated in BISC-E last year, so he's going to tell a little bit more about his project and his experience. And then I'll tell more about the practical stuff of BISC-E. It should be working. Oh, it's the same thing again, probably. Yeah, okay. So, Edwin, please. Thanks.
Edwin, if you can stand a little bit more there, and even more visible in the camera.
Am I visible like this?
That would be great, yes.
Okay. Well, welcome to everybody online. I cannot see you, but you can apparently see me. Some people here in the room. I'm going to tell you a little bit about bio-based economy, what it entails, and giving some examples. It will not be too elaborate or complete, but that gives you a bit of an example, a bit of a sketch what bioeconomy is. As Elisa mentioned, my name is Edwin Hamoen. I work for Wagen Food and Bio-Based Research, where I try to set up all kinds of projects, research projects to look for bio-based products out of all kinds of biomass, residues, and agricultural streams. And at the same time, since 1st of January of last year, I also act as one of the directors of the Dutch Growth Fund, Bio-Based Circular, where we try to accelerate the implementation of bio-based plastics. That's a subsidy fund that we got from the government of more than 300 million euros, so that's quite a bit. But I will tell you a little bit about my experience and ideas on bio-based solutions for fossil-free products, because that's actually where we want to go. Fossil-free products as part of a bio-based circular future. Well, this is a nice sketch that my colleagues and I made the past year, where you see that in the future, and then in future we always talk about 2050 as a direction. In the basis, nothing really should change. We should still live the life that we have now, but we should base it on different resources. But that's the basic starting point. But it does mean that we need to act differently, produce and consume differently. Yes, and why do we do that? Well, first of all, because everybody knows the climate. We're heading for temperature rise, so we should stop using fossil resources for all our energy fuels, but also materials needs. For energy and fuels, we're already doing quite a bit, not enough, but still, we're working on that globally. But for materials, that's lacking behind quite a bit. So we need to make an effort there. And that means that we need to adjust our consumption production patterns and especially look for smarter sourcing and using of what we have here on our planet, within the planetary boundaries that we have. This group. Maybe you can do it again, because this one's not good. Because 88% of the materials that we currently have, based on chemicals, are still based on fossil resources, oil and gas, and that's what we need to stop. And yes, of course, in 2050 it will not be 0% fossil, but we should have it as low as possible. So that's the ambition, to go from 88 to 0. And for example, if you look at the total plastics market, it's about 400 million tons of plastics. That's a tremendous amount. We only expect that it will increase. So the urgency is quite big. And at the moment, only, oh, that was the wrong button. I thought it was the pointer, but it wasn't. I think that's the one, yeah. Ooh, no, that's not.
pointers work?
At the moment, only 8% of the chemical materials is based on biomass. There's a little bit of recycling and a very, very little bit based on CO2. But these are the three sources that we need to rely on for the future if we want to step away from the 250. And this is a picture that has been prepared by Nova Institute, a German, very well recognized institute that does predictions, especially in the chemical industry, where they expect the growth in chemicals and derived materials up until 2050, where they expect a doubling of what we need in the end. And if we at the same time want to step away from fossil, well, you can see that the challenge is quite big. If we, of course, we need to recycle as much as we have and as much as we can, but we cannot recycle everything. And we expect that if you can achieve 50% recycling, that will be already quite a big achievement. But that does mean that the rest needs to be based on biomass or on CO2. Well, CO2 is very promising, but still will take a few decades before we will be able to do that at scale. So the urgency for developing bio-based products is quite big. And luckily, there are quite some efforts, but it still will take some time. Well, this is the mission of Wageningen Food and Bio-Based Research. Well, I will skip that, but it's nice to know that it's good to know that it's not just looking at technical feasibility, but of course also economically viable, circular, but it also has to be good for the health of the human being and for within the planetary boundaries. And also look at things like biodiversity and stuff. Well, now we go a little bit into the examples. And the first one is looking at sugar beet. Sugar beet, we all know for the sugar that we use and consume all the time. And we should reduce that a bit. But there is a lot more that you can do with this beet, not just with the sugar, but you can also make plastics, for example. But there are also all kinds of other components in such a beet and in the leaves, which you can use, for example, for paints and coatings, but also in personal care. All kinds of creams. You can utilize the components that are present in sugar beet. A company like Suiker-E is already doing that, also looking at taking out the fibers, for example, for paper making. And all the rest that remains after utilizing as much as possible, they put in a digester to make biogas, and so that we can use that to replace natural gas. So it's always a challenge to utilize as much as you possibly can from the biomass that we have within, of course, economic boundaries. And also to make sure that you preserve the land, because if you take everything from the land, then the land will go down in quality and you cannot do anything with it anymore. So that's also a very important criteria. Another example, currently the asphalt for roads is based on two components, stones and the very heavy fraction from oil, bitumen, and that actually acts as the glue between the stones. And at several places in the world, also here in Wageningen, but other places as well, we have developed an extraction method to take out this lignin from plants. Plants are basically lignocellulose. To take out the lignin, you can use that as a glue, and with that replace the oil, so that we don't need the oil there anymore. And actually, a few of the bicycle roads here have already been replaced with these combinations. So that's very nice, but it's not something that we will develop in the coming couple of months. But it's also one of the things that we're working on. And this can actually be quite big if you know how much roads there are being paved every year. Then that is quite a big impact that you can make here. Yes, well, this is a picture which I sometimes use from my role as director at Bio-Based Circular, the Growth Fund, where we really look at bio-based polyesters, plastics, but in the typical one, which is polyester, which can be recycled very well, but is also biodegradable in the end. And polyester, everybody knows that, for example, in clothing and carpeting and stuff. but also, of course, PET bottles for colas and Fantas. That's only one type of polyester, but there are many, many more, which we should develop because they are much easier to biodegrade because of the structure. And there are quite some applications where you can use that. But the reason why I put on this sheet is because of these two comments here in the middle. It does not just need to be based on biomass to replace fossils, but at the same time we should make sure that it is as much as possible circular, so that it doesn't leak into the environment, but also to have it as a renewable feedstock for all our materials. And if it is ending up in the environment, we need to make sure that it does degrade over time, and not within a couple of months or so, because it still has to have the right specifications for what you use it for. But in the end, it should go. And if you, for example, utilize now the polyethylene plastic bags and all kinds of other materials, if you put that in nature, it will stay there for hundreds of years. And that is something that we need to avoid at all time. Well, here you see a few examples of what we are working on in the packaging of PET bottles. There's an alternative, PET, which is made by, or going to be made by a company in the Netherlands called Avantium. They're working hard to build a plant there. Well, the plant's already finished, but it's starting up in there. So also we're looking at applications in the building sector. You can imagine that you can change a lot there. And also in textiles, so there are many more applications. Okay, just some examples what you can think of on what you can do with your biomass, which is already happening. Here at the bottom you see, for example, insulation based on, well, this is actually based on hemp. That's a very versatile feedstock which you can use for example, insulation, but also boarding. And this is bitumen-free roofing, so the roof of your house can be made from bitumen, like the asphalt, but also then we can make the same shift as we did for asphalt. Well, here this is a chair which is already on the market actually, from natural components, natural fibers, flax in this case, together with a natural binder. Bioplastics for packaging, and also home and personal care. Not just the packaging itself, but also the contents, the cosmetics themselves are more and more based on natural components, which in the past was not always the case, or in most cases. You can help me there. Okay, some more examples. On the top left, you see the agricultural plastic. This is now used in a lot of cases by the agricultural sector, where they need to cover the land. But if we can change that and put down some biodegradable plastic, that would of course be a lot better, because a lot of this plastic tends to blow away in the wind and then it ends up somewhere and it stays there. Then you see here an egg box which is made from 50% from grass and the rest from recycled paper. This actually is a museum in Amsterdam, where the site is made from natural composites, very strong and very light. Well, you see some cones and coatings and paints which are bio-based. Well, you can not see that from this picture, of course, but that's happening also in the Netherlands. Packaging, cups, and again, also this type of glue can also be made from bio-based. But if I say can be made, that means yes, it can. The companies are working for it. Are they on the market? Not always. And are they economically viable? Well, we still need to make some improvements there. And are they already at scale? No, not yet. So only a few examples are really on the market at a good price and people are using it. But it's still a challenge to make sure that we can scale it up and also convince society to utilize them, have trust that it's the same quality, and it's actually better for the environment. So let's see. Yeah, and then we go to those are the type of products that we can make. It's only examples. There are many, many more. If you look around you, everything that is made from oil should be replaced by bio-based products. But where to base it on? Well, I've put down some examples here. Let's first start with the left-hand corner. But best, of course, if we can use waste, organic waste, to convert that into all kinds of products. Possible, not that easy, but it is possible, and it is a source which is, of course, cheap, and we need to do something with that. Or this, for example, is already put in a digester, so we make biogas, but we can make more. We can go to a higher value. Corn, especially in the United States, a lot of corn is already grown and converted into ethanol for fuels. Okay, it's a good step, but we can do better. We can perhaps produce all kinds of other materials which are higher on the hierarchy of value. But also wastewater. Right? You can also produce plastic, for example, from the contents of wastewater. And at the same time, clean the water so that we can utilize it again. But there are also, of course, also a lot of fibers which we can use. Wood, chips, potatoes, but not just the potatoes, but also the plants we can utilize. Happens already, not just the potato itself, but also the peels are being used. Manure, we have a bit too much manure here in the Netherlands, and there are a lot of efforts to convert that into useful products. Quite some challenges, but it is still an opportunity that we should look at. And for example, the mushroom is also a very nice primary crop that we can use for all kinds of products. We're actually looking into making packaging out of the mushroom itself, but also here the bed, which is fully grown by mycelium, is now a waste product, and quite some parties are now looking into what can we do with the waste products. I think that's it. Yeah. Do you want to do questions now or later? Or are there any questions online?
Yeah, maybe if someone has really burning questions now, later on there's going to be more time for questions. So if you're online, then please put your question in the chat. Are there any
questions? In general about the
challenge.
Okay, so not
yeah, it's not something that I can answer.
No.
It would be great, maybe one more moment to share some results of the previous challenges, perhaps, as an inspiration to say that what were the ideas students worked on so far, or where to find it.
Yeah, I'll share that later. Yeah?
Yeah.
Okay, thank you very much. Then next we got Teun.
Yes.
He's joining online. You're there, great.
Yeah. Do you hear me?
Oh, I stopped sharing. It's not. What I wanted.
Okay, great.
Okay, we can hear you now, I think.
Perfect.
Okay, great. Yeah, so Teun is gonna talk about his experience.
Yes. I think you have the slides, right?
Yes. So if you want to go to the next one, just let me know.
Yeah. Okay, shall I start?
Yeah, go ahead.
All right. So, yeah, hello everybody. My name is Teun Perdok. I am part of the Biomiler 2.0 team, and yeah, we were the team that won the Dutch competition last year. So yeah, I was asked to tell a little bit about my experience in doing this. So let's go. You can go to the next slide. So here I have some pictures. The pictures. We were the national winners of the Netherlands, and on the picture on the left top there was the European round. So first we had a round with all 20 countries that were participating. Then we went to the finals, which was with 5 countries, and then we became fourth. So unfortunately not top 3, but I think we did a great job. Yes, get to go to the next one. So I'll first, I think maybe it's nice to explain a little bit about what we did. So we created the biomiler. A biomiler is a composting reactor that generates heat and high quality compost. It was an already existing innovation due to so you put in all types of organic material and add water to that, then it becomes very warm and it starts composting, and then you get heat and compost out of it after 2 years. And you can of course use this heat for heating appliances. So for example, for farmers, they can use it to heat their stables or whatever. So you can go to the next slide. We decided that we wanted to create a biomiler 2.0 that consists of 2 major innovations, which are 1, an active aeration system, and 2, a condensing heat exchanger. You can go to the next slide. I tried to keep it short, but I also have the slides a little bit about what we did. So first we had an active aeration system. Usually biomilers were aerated passively, but then there was a problem that not the entire biomiler got enough oxygen. So we created an active aeration system, which was controllable. You can go to the next slide. And then so this is how we designed it. We actually built it at the site of our university campus in Utrecht. We built this entire biomiler, and this was an active aeration system. So with this, we were able to secure better compost quality and more heat output. And then to the next one, and the system became more reliable. Then we had another, the next slide, we had another innovation, which was the way we extract heat from the system. So usually it's done with a within-pile heat extraction method. So then you capture the heat through conduction. However, as you can see, there is also a lot of rising water vapor that contains heat. So we wanted to also capture that, and therefore we created our system, which is you can go to the next one, the condensing heat exchanger, which is placed on top of the biomiler. And then again, with this system, you're also able to extract the sensible heat as well as the latent heat in the rising water vapor. So we are able to extract more heat from the system. So this again, to the next slide, 2 major advantages. And so this was basically RRD. And you can go to the next slide, I think. So this was basically RRD. But then for the BISC-E, it's also the jury finds it's very important to also see to what extent your innovation is feasible and to what extent it really helps in a bio-based circular economy. So that's why we also included several calculations. We calculated that we knew that we had to fill our biomiler with compost. And a very solid question to ask is how many biomilers can you build then? Well, we calculated that we have this amount of compost in the Netherlands. And then we came to the conclusion that we can build 60,000 biomiler 2.0s. And then to the next slide, there we also had a calculation on why our biomiler 2.0 is better than the normal biomiler, which is of course because the advantages I already mentioned, but also we had to do a sort of an economic analysis. So we compared the payback rates of the usual biomiler system and the biomiler 2.0 system. And we presented all that. So I think that's really a thing that also got the attention of the jury during our presentation, is that we really tried to have a broad vision of our system, and we included the technical analysis, which is sort of what I started with. We had an economic analysis, a societal need. We also had a societal need for our innovation, which is of course the pressing situation in the Netherlands for farmers, and this is a very sustainable way that they can use their own compost to create better compost and generate heat. So those are, I think, the 3-4 main pillars that you get assigned to be they say you should focus on that, and that's also really what we did, and I think that really helped us in creating a good presentation. Then you can go to the next slide. So a few important things I would like to say for when you want to participate in this. It is clearly stated that in every round there are different priorities. So first you have, for example, in the first round you focus more on the technological side of your innovation, but then when you go through, you go to more in the you have to focus more on the financial and innovative side of your innovation. So you really have to be aware of what does the jury want to hear from me. So, for example, you first had a jury which was more with professors and people from universities, etc. But the second jury for the European round was more with people from the business side. So they also wanted to know more about the financial side, to what extent is a societal need for this, is it financially viable, etc. So therefore, I would really recommend, or my entire group would recommend you to really prioritize what the jury wants to hear from you and make sure that you have everything covered in your innovation. Also, we practiced our presentations very often, also with professors from our university. So we had several sessions with professors that helped us, and then we created the presentation as good as possible. I also recommend you to do that. Just ask people that know about this, like, hey, can you help me? It helped us a lot because they really gave us very valuable input in how we should make our story more consistent and good. Also, in the beginning, you want to make it very scientific, the presentation, because it has to be backed up by science. But also, don't overdo that in your presentation, especially not when you're presenting for the more business-oriented people, because that's what the thing what I was trying to say earlier. You have to keep aware of how you focus in the different presentations. Then try to always focus on your main message of your innovation. So why is your innovation the best? And practice your presentation a lot, as I just said, and really own what you say. I think we were actually building our innovation. We were busy with it. We were very busy with this project, the BioMiler 2.0 project. So we worked on it every day. So we all knew the ins and outs of our project. And I think that's also really valuable to make sure that you know everything about your project and that you can speak fluently about it, answer questions that are asked. And I think if you do that, you have a very good chance of becoming far. And overall, we find it very cool to do this last year. Especially very cool that we were able to go to the finals, which was it was very nice to do that. We learned a lot. Also we learned a lot about our innovation, but also about how to present and how these things work. So I think it was a very valuable experience for our team. And we had the nice thing that we also actually built our BioMiler last September. So now it's also up and running at the university site. But your innovation it doesn't have to be a build. It can also just be an ID, and because we also had other teams that had maybe a little more complex IDs, so they needed much more money, etc., to build it. That's I think that's the main things that I wanted to say to you, and we enjoyed it a lot. So good luck with your journey.
Question.
Okay, thank you very much. Thank you. Now we can also see you. So Teun has to leave in a bit, right? So
I'm happy to answer a few questions if that's okay, and then I have to leave indeed.
Yeah. Okay.
If there are questions.
Are there any questions here in the audience? Online?
From me.
From you?
How much did you spend on average working on the challenge?
How much we spent on the entire thing?
Yeah, time. How much time?
How much time?
Not how much time.
Good question. I think yeah, we were with a team of 4 people, 5 people, 4 or 5. Of one dropped off after a while, but so we were also able to manage the time and divide our tasks. But for example, in the report that we had to write in the start, you have to write a technical and innovative and economical part, and we just everybody did their own part. So I think that was really helpful. Also in the time management part. But yeah, to give it a number, good question. I would say before the Dutch round, I think maybe 10 to 20 hours each per person maximum.
Per week?
For me,
In total. Yeah, well, we spent a lot more time on our biomiler, but just on the BISC-E side, yeah, I think it's a difficult question for us, because as we were also actually building this biomiler, and that also cost quite some time and money, etc. So that was also a thing we were very busy with. And then also during that time, we also did a lot of research, which we used in our BISC-E presentations. So yeah, I think it's a bit difficult to give a number to that, to how much time you would exactly need for the BISC-E part. So
yeah, so it's basically a little bit of a choice on how much you want to invest in it, and also basically dependent on your projects, I guess.
Yeah. So yeah, I think it's hard. It's difficult to answer that question.
Yeah. I see another question in the chat. What type of questions was the business panel asking?
Yeah, there were more questions. Let me think. Well, they went more into that with the business idea of our thing. So they want questions like, how exactly do you want to commercialize it? How do farmers really financially? How certain is it that there is a financial benefit with your thing? What are the uncertainties in your innovation that could reduce the benefits over time? So more like that. So we had, I think, pretty straightforward questions, more about really the business idea and how solid our business idea was for this biomiler. I think that's the type of question that they asked us. Yeah.
Okay. And can you tell us how you found your team members?
Yeah, we're all students from the Utrecht University. So we just found each other in class, because we had this idea of building the biomiler, and then some professor came up to us and he said, hey, you should know about this BISC-E challenge. And then, but we already had our biomiler team, so then we joined this BISC-E as a team. So, yeah.
And what was the most challenging?
What was the most challenging? Well, I think getting the presentation right, especially for the I think for each round, it was sometimes quite challenging to really decide what we want to focus on our presentation, because we didn't use the same presentation in the national round as we did in the international round, because there was a different focus. So I think that was really hard for us, that sometimes we were, okay, what should we, because you want to tell so much about it, so what should we leave out and what should we exactly tell here? I think that was a thing we struggled with, and that's what we also used our professors' knowledge, etc. for. They helped us with that, so they said, okay, you should focus more on this or this. So I think that's the thing that's really important, and I think that was hard for us. Yeah.
Okay. And can you just say a little bit about your finals experience? So, like when you went to Brussels, how did it go? How was it?
Yeah, well, we didn't went to Brussels. That was a pity, because I think, I don't know if they changed it just for last year, or if that's this year. If this year that's the same, but all the international rounds were online, and only the people that went top 3 of Europe. So there were 20 countries participating, and the top 3 countries, those were invited to a sort of how do you name it? A networking event, sort of a congress. And there they could speak more about their innovation. But that was after it's only if you became first or second or third, and we became fourth. So we weren't able to go to Brussels. So yeah, everything was online for us.
And now for this year, it's gonna be a little bit different. They are planning to do a final in real life, maybe only for top 5. I'm not sure about that, but they are
Yeah,
busy on working.
that's nice. That's nice.
Okay. So another question. How did you come up with the idea of developing the biomarker?
Yeah, it was a friend of mine. He Lasse, the team member. He does other work in Germany. He came in Germany a lot for his work, and then there he at farms, and there he saw a biomiter from a German farmer, and then he was like really enthusiastic about it. And he told me about it, and then we were like, okay, yeah, this is a cool idea, but as it's so small, there are probably some pitfalls in it. So how can we? Then we just thought, okay, how can we make this system potentially better? And then we dove into the literature about biomilers, composting heat reactors, and then we decided, okay, we want to do this and this, and maybe it becomes better. So I think it's just it was maybe sort of luck also that he came across the biomiler, and from there on it we began.
Okay, thanks. Any more questions? Okay, then thank you very much for.
No problem. Thank you.
Thank you.
Okay. Yeah, I also have to leave because I have class now. So.
Yeah, of course.
See you.
Bye.
Bye.
Okay, let's see. Okay. Okay, so then this is the last part of the info meeting of today. So more practical information on BISC-E so that you know what you're signing up for, basically. Okay. So what is the challenge? Well, I hope you kind of understood by now that you're supposed to come up with a bio-based product or process. So going from fuel-based to the bio-based. But it really can be all sorts of things. Like examples of previous years were that they made food source of mycelium, or they made you have those plastic microbeads, and they made a biodegradable alternative for this. And of course the biominer. So it really can be all sorts of different products that you come up with. But a few things that it has to be, or that you have to think about, is that first of all it should work. So technically it should be like a real option. It should be innovative, so really something new and improving. Of course you want to have a positive environmental impact compared to the conventional products that's on the market right now. And it has to be economically feasible, because otherwise you can come up with a really great idea, but no one's going to be investing in your idea if it's not economically feasible. So who is it for? Well, you should always Dutch, or students from Dutch University or University of Applied Sciences, but I think that's okay. And I got a question, this question a few times. So you have to be registered as a student at the beginning of the challenge, which is basically now. It's okay if you end your studies in March or April or May or before the finals. That's totally fine as long as you're a student now. And you're gonna work in teams from 3 to 6 people. So you can sign up as a team. If you found team members already, you can also sign up individually, and then we'll point you to a team. Okay, so the timeline. So this is where we are right now, of course, at the info meeting. Then the next important date is the 10th of March, because that's the deadline for registration to BISC-E. Right after that, on the 19th of March, we have a kickoff event. So this is where we are now. The deadline, important thing as well, that if you register as a team, every member of the team needs to register individually. And you need a team captain, so basically the point of the contact person in the chair. Yeah, and so then after you register, we have the kickoff event on the 19th of March. It's going to be in Utrecht, very close to the central station. And the program might still change a bit, but we have keynote speaker there. There's going to be workshops. There's going to be people who help you develop an idea, or if you already have an idea, get some tips and feedback. Yeah, you're going to meet each other, network a bit. That's the idea of this. So it's starting at 4. It's a walk-in from 3:30. It starts at 4, and then we're gonna end with something to eat probably. Okay. Then we have another contact moment, which is on the 14th of May. It's gonna be a pitch workshop, because in the finals you're gonna have to prepare a pitch. So we're gonna teach you a little bit more about what the important things are if you're giving a pitch. And this is also gonna be a moment of feedback from experts and professionals. And this is also gonna be in Utrecht. Then you've worked on your project for quite some time, and in June you're gonna have to hand in your documents. So you're gonna make a report. As I said before, it's possible that you really make your products, but it's not necessary. You don't have to make a prototype or anything, but you do have to make a report with a short description, with saying why it's innovative, the technical explanation, the explanation of the environmental impacts, and then also the economic viability. So all aspects are going to be in the report. And then we have the finals. The finals are on the 10th of June, and it's going to be in The Hague at the World Biomarkets. This is like a very big conference kind of event, and you're going to have free access to it. It's pretty cool, and we're going to have a room there where every team gives a pitch, and then the top 3 can pitch their idea on the stage. So this is really cool opportunity for you to also network there a little bit and get more inspiration from what's going on in like real life business.
It's a really nice conference. I've been there twice.
Okay.
A lot of companies sharing what they're working on. They're probably very interested to hear what you as a student teams are going to suggest.
Yeah.
So, very much.
Yeah. It's a really great opportunity to make some connections there. And then the jury is going to be there as well. And so we have first 2 pitches by all teams, then the top 3 pitches on stage, and then we have the announcement of the winner. So if you win the Dutch competition of BISC-E, you win €1,000, which is pretty nice, but you also continue to the European finals. And there you again get some trainings or workshops. And like I said before, I think it's 2 rounds. I think the first round of the finals is going to be online. I'm not sure, but I think so. And then the second round is for the top 5, and I think that's going to be in real life. If you become top 3, you get another, more money, more prizes. But there's also, they're going to give you more support. You're going to be a member of the Bio-Based Industry Consortium. And they help you to develop your idea a little bit further and connect with the businesses from this consortium. So why should you join? Well, I said before, it's really great opportunity for your network. We also really learn a lot from this. It's really a valuable opportunity next to your studies. So it's because it's more, because it's challenge-based learning. It's a different learning experience than just following a course. You get feedback on your idea. You gain visibility in the sector with the businesses right there. Opportunity to win nice prizes. And from some universities, it's possible to earn credits for joining this. I know that unfortunately for Wageningen it's not possible, but I also know that for Delft it's possible to do this instead of your internship. For the rest, I don't know, but you can always contact your study advisor or something to see if there's something is possible there. So what's next? Well, if you don't have any team members yet, try to find them, ask your fellow students or some people in your network or people that are now online or here. And then, of course, you have to register if you want to join. So again, the deadline is 10th of March, and every team member needs to register. And it would be nice, it's not necessary, but it would be nice if you can find someone from your institution to support you, some teacher or PhD student or whatever. So it's not necessary, but it's nice to have someone who gives maybe some extra feedback or helps you a little bit with your idea. Okay, I think that was my last slide. So are there questions for me or Edwin?
There was a question about the first event, the kickoff event. Maybe you can, what time it starts?
It's walk-in from 3:30 and it starts at 4. I'm still trying to find out if it's possible to join online. Oh, something I did forget to mention is, so you're in teams with 3 to 6 people. In the finals, there's going to be, have to be at least 2 team members present at the final. So it's okay if some of teams, some people won't be able to come. That's okay as long as there's 2 people, and that also kind of counts for the kickoff event and for the workshop. So I'm still trying to see if you can join online as well, if that's a possibility or not. So I'm not sure about that, but it's okay if not the whole team is there as long as there's going to be part of the team. Basically. Any more questions?
I think there were a couple of questions about the type of solutions. Especially, I think 2 teams are thinking about more social interventions rather than technical. Any comment on that? We already are in contact with those teams. They will be sending us their ideas, but if you can provide some suggestions for teams who think there's already so much technical solutions, but actually the problem is that we are not picking up on social interventions.
Well, I fully agree that it has to be, if we want to make this happen, we do not just need technical innovations, but also social, even more so than I thought a few years ago. So yes, I think there's quite a big need for social innovation, social intervention as well. I just do not know whether it fits the scope of BISC-E. I don't know.
In the BISC-E regulation that was mentioned also before, it's about the technical possibility, as well as the economical, and then economical you can include social as well. And the innovative part, but also the sustainable part. And that's something which was not mentioned yet, but if you have a technical solution, maybe to produce something where you use a lot of energy, then it might be, you might end up with a very nice biodegradable product. But if you look at the whole chain and the whole production, it might not be as green as you might think. So the sustainable side of your invention is also very important. So we have had a few examples in the past where people started with a very watery solution of something, and then they dried it and to collect the compounds, and then use the compounds to make something. But they used so much energy in drying that in the end all the sustainability benefits were lost. Yeah. So it's and the idea of the BISC-E is that you look from it from an integrated point of view. So if there are people who have really only a societal or economical background, I would suggest combining that with other students with a more technical perspective, and then organize a very good team. That's done also in the past with, for instance, students from Delft joining up with students from Groningen.
Yeah.
So.
But I think a purely social intervention, which I would actually like very much. I don't think that when the intervention is just in the social sector, that it would fit the scope of BISC-E. But I do agree with Gerlinde that if you can add a good social intervention to your technical innovation, that would actually make it much stronger.
Yeah. Also in the report, there's space for the societal impacts to write something about that as well. It's also important. So yeah, if you're more societal background, then please team up with someone with more technical background, maybe so that you can combine those strengths. Okay, any more questions for?
No, I think it's a follow-up on the first.
Okay.
Yeah. Yeah.
Okay.
We can wrap up maybe for the online part, and you guys are welcome to stay here a little bit longer and we get to know each other.
Yeah. So the my part of the presentation is gonna be on the website in a few days. I'm not so sure, but it's gonna be on the website, so you can look something up, and you can always send me an email. Yeah. Okay, so you can send an email to BISC-E@word.nl or Elisa van Gelder, elisa.van-gelder@word.nl. You can always also follow us on Instagram and LinkedIn. So I'm gonna be putting some updates there as well. So yeah, thank you all for joining us today, and I hope I'll see your registrations coming up soon.
Yeah.
Thank you.